Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 8.1b on our series on adding and subtracting fractions. We're going to be taking a look at how to add and subtract mixed numbers in this presentation. A sample of what we're going to be covering in this tutorial is given here. Find the sum of the given mixed numbers 2 and 3/4 plus 4 and 3/8. Don't forget, we have a collection of practice problems at the end of this presentation for you to try out in order to demonstrate mastery of the contents of this presentation. Alright, we have the steps that we're going to be using to add mixed numbers outlined on the right here. It's very similar to the steps that we used in the previous presentation, 8.1a. Where we're just adding fractions. The only difference here is that we're going to be adding an additional step, which is converting the mixed numbers into fractions. Okay, after that, you find the LCD, make equivalent fractions with the same denominators using the LCD, add and subtract numerators, keep the denominators the same, and simplify your answer where applicable. Okay, so our question number 1, we are to evaluate the following. As instruction, evaluate the following. So let's say we're given two mixed numbers, okay, 2 and 3/4 plus 4 and 3/8. Now there are two ways to add mixed numbers, okay, add and subtract mixed numbers. I'm going to use one particular method. This method is by converting them into improper fractions. Why am I using this method? It's the easiest method to use in all cases. Okay? When you are dealing with the other method where you add like groups of numbers, for example, you add the whole numbers and the fractions, there is a possibility of making mistakes when you're dealing with the subtraction situation, because you have to borrow and then it's much more involved and complicated. So I'm just sticking to a method that works for both operations, addition and subtraction. And also when you think about multiplying mixed numbers, is also more effective to use this approach also. Okay, all right, so that's what we're going to do. We're going to use a method of conversion into improper fractions first. Okay, so we have 2 and 3/4 plus 4 and 3/8. So what we're going to do is we're going to convert to improper fractions. And then we can then apply the procedure that we used in the previous presentation, 8.1a, to solve the problem. Okay? All right, so starting with 2 and 3/8, we already know how to convert mixed numbers to improper fractions. If you've forgotten how to do that, you can take a look at the QR code we presented earlier at the opening of this presentation, or just go to the playlist and then you'll see that tutorial there. Okay. All right. So to convert 2 and 3/4 into improper fraction, we're going to multiply the denominator of the fraction component with a whole number, add it to the numerator, and then divide it by the denominator. Okay. So the operation is 4 times 2 plus 3 divided by 4. Okay, using the order of operations, please excuse my dear and Sal. You multiply first. 4 times 2 is 8 plus 3 over 4, and that gives you 11 over 4 as your answer. Okay, so the improper fraction form of 2 and 3/4 is 11 over 4. Let's put it right here. So first one becomes 11 over 4, and then we're going to be adding the second fraction. So we're going to change this mixed number to improper fractions, okay? 4 and 3/8. Same procedure, multiply the denominator by the whole number, add it to the numerator, and then you divide it by the denominator, okay? So we're doing 8 times 4 plus 3 divided by the denominator of the fraction, which is 8. Okay, using order of operations, 8 times 3 is 32 plus 3 divided by 8. Okay, and then 32 plus 3 is 35 over 8. Now the problem is now 11 over 4 plus 35 over 8. What's the difference? We're now adding fractions. Okay, so you might wonder, why are we converting it to improper fractions first? Well, remember, when you're adding fractions, in order to add fractions, the denominators have to be both equal to the LCD. Okay, so we're now going to go ahead and find the LCD of these two fractions, and then we'll be able to apply the appropriate addition algorithm to adding these two fractions. Okay, so let's specify what we're about to do now. What we're going to do is we need to find the LCD of the two fractions we're adding, 11 over 4 and 35 over 8. So to do that, let's go ahead and use our LCD chart. We're going to extract the denominators of these two fractions. We're going to look for the LCM of the denominators, and that will be the LCD of the fractions containing those two numbers as your denominators. Okay, so we'll put the smaller one first, 4, and then 8. Okay, so now we're going to list the multiples of 4 all the way to 8, or until we hit 8. Okay, sometimes the bigger number shows up in the multiple of a smaller one. In that case, you stop right there, because that's equivalent to the first multiple of the bigger number. Okay, all right, 4 times 1 is 4, 4 times 2 is 8. Oh there, look at this. We already have the second number showing up in the multiple of 4. What does that mean? We stop right there. 8 times 1 is 8. Ladies and gentlemen, we automatically have the LCD. Okay, so that goes your LCD of the two numbers. Okay, so let's rewrite the problem. 11 over 4 plus 35 over 8. Okay, so now the goal is to make the denominators equal to the LCDs and converting the entire fractions. We're now going to multiply 4 by the number that makes it become 8. So 4 times 2 is 8. So multiply the numerator by the same value. And then 35 over 8. The denominator is already 8. The denominator is already the LCD, so you don't do any changes to 35 over 8. Okay? Okay, so now let's multiply this out. 11 times 2 is 22 over 4 times 2 is 8 plus 35 over 8. So now that the denominators are now the same, okay, we're now going to be able to add. How do you add fractions? You add the numerator, right? And keep the denominators the same. Bam, like that. 22 plus 35 is 57 over 8. All right, this is the improper fractions form. If you want to write it as a mixed number, let's go ahead and divide. Put out your long division bar. The top dog goes in the doghouse, divide by 8. 8 goes into 56. So if you look at your multiples of 8 up to 7, 7 is the biggest multiple of 8. That's smaller than 56. 7 times 8 is 56. And then you subtract, and you have 1. Bam. All right. So it's basically 7 whole number, remainder 1 over 8. So 57 over 8, or 7 and 1/8 is the answer to question number 1. Okay, so this is an example on adding mixed numbers. Now let's take a look at an example on subtracting mixed numbers. Okay, so for number 2, what if we have 3 and 3/7 minus 2 and 1/8? We're going to be following the same procedure that we used in number 1. So we're going to be going a little bit faster here. So what we're going to do is take these two numbers and convert them into improper fractions. Okay, so let's write down what we're about to do. Convert to improper fractions. All right, we're going to do it one at a time. The first one is 3 and 3/7. So we know the deal for the conversion. 7 times 3 plus 3 divided by the denominator, which is 7. Using your order of operations, 7 times 3 is 21 plus 3 over 7. 21 plus 3 is 24 over 7. Okay, so 3 and 3/7 in improper fraction form is 24 over 7. We're going to apply the same procedure for the next mixed numbers, 2 and 1/8. So you're going to have 8 times 2 plus 1 divided by the denominator, which is 8. Following the order of operations, 8 times 2 is 16 plus 1 over 8. And then that becomes 17 over 8. Okay, so the second fraction is 17 over 8. So now what we're going to do is we need to find the LCD of these two fractions. Okay, so let's do that. So we want to find the LCD of the two fractions, 24 over 7 and 17 over 8. So when we find the LCD, we can convert them into equivalent fractions with 8 with the LCD as their denominators. Okay, so 7, put the small one first, the bigger one 8. Multiples of 7 all the way to 8. So 7 times 1, 7, 7, 2, 14, 7, 3, 21, 7, 4, 28, 7, 5, 35, 7 times 6, 42, 7 times 7, 49, 7 times 8 is 56. Multiples of 8, 8, 1, 8, 2, 16, 8, 3, 24, 8, 4, 32, 8, 5, 40, 8 times 6 is 48, 8 times 7 is 56. You see a common multiple with these two numbers? Yep, it's 56. Okay, so the LCM of these two numbers is the LCD of the fractions that have 7 and 8 as your denominator. So the LCD is 56. 42, 56. All right, so let's write the fractions. 24 over 7 minus 17 over 8. We're going to write them as equivalent fractions with 56 as the denominators. Okay, 7 times what gives you 56? 7 times 8. So the same applied to the numerator. So if we multiply this out, we'll have 192 over 56. These two fractions, 24 over 7 and 192 over 56, are equivalent fractions. Okay, the only difference is that this has a denominator of 56 and a different numerator too. All right, so the second number is 17 over 8. What do we multiply 8 by to hit the target LCD? 56? 7, right? So the same applied to the numerator. We're just multiplying by a version of 1, 7 over 7. So 17 over 8 will not change in magnitude or value, right? Okay, so 8 times 7 is 56. Beautiful. And then 17 times 7 is 119. So now that we have identical denominators, all we're going to do is subtract the numerator and keep the denominator. Okay, 192 minus 119 is 73. That goes your answer in improper fraction form. If you want to write it as a mixed number, let's do the long division. Okay, top dog goes in the doghouse, 56. 56 goes into 73 once, and then multiply 1 times 56 is 56. Subtract, you get 17. Okay, so it's basically one whole number 17 over, let's write that again. One whole number 17 over 56. So our answer is 73 over 56, or one whole number 17 over 56 in mixed number form. So ladies and gentlemen, there goes your answer to question number 2. Okay, now it's your turn to do some practice problems. All right, so here are 4 practice problems for you to try out. So go ahead and pause this video at this time. Try out these practice problems. When you're done, click on the playback button, and we're going to reveal what the correct answers are. Alrighty, welcome back. So here are the answers to question 1 to 4. Go ahead and compare it with your work. Let us know how well you did in the comment section below. If you got them all right, go ahead and destroy that like button for us. If you have any questions, specify it in the comment section, and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. Don't forget to support our channel by liking, subscribing, and sharing the contents of this video with your friends. Tons of support resources can be found on Mathgotserved.com. Do check it out. Thanks again for watching, and have a wonderful day. Goodbye.